So have you ever been in a situation where you ask a large language model like ChatGPT or Llama about like something specific, maybe NFL games, or to help you with a new released tool or framework or a library, and all of a sudden instead of like hallucinating or making things up that don't exist, or just simply saying that I don't have the enough knowledge to answer the question? Well, that's simply because of the two main problems of large language models. First, they don't have access to real-time up-to-date data, and second, they are prone to hallucinations, and it's very hard to stop this. So how does a RAG fit in all of this? RAG is the solution to these two problems, and it's actually the perfect solution. So the following diagram in here demonstrates how a RAG works behind the scenes. And of course, a RAG stands for Retrieval-Augmented Generation. So originally, a normal user, whenever he tries to talk to an LLM and get something like answered from an LLM, for example, he needs to get some new information about the newest Tesla Roadster. So he goes and actually asking an LLM and say, oh, what do you know about the latest Roadster from Tesla? And if the LLM is actually up to date and recently trained, it can actually easily go ahead and answer or give you the right answer. But if it doesn't have the information or have the data related to the Roadster or the recent news, it won't be able to actually give you the right information you're looking for, and it might start hallucinating by making things up that doesn't exist. And hallucination is a very bad problem, because sometimes the LLM doesn't know when it knows something and when it doesn't know that thing. So as I said before, the solution is the RAG, and the simple diagram in here shows you how a RAG works behind the scenes, from when sending a prompt from the user to, finding the context and everything. So simply the user starts by sending a simple prompt like Tesla Roadster in here. Like instead of just going directly to an element here, it just goes to the retrieval, and this is actually our RAG architecture. So it goes to the retriever. You can imagine this as like a search engine you have implemented behind the scenes. So the retriever in here takes the prompts in here and tries to look for related information and data on your context database. And this context database is going to be a vector database, specifically a vector database. It cannot be a regular database, because only vector databases can, have the ability to do like semantic searching and properly finding exactly what we're looking for, depending on the provided prompt. So once you do that, the context database is going to like return a specific context related to the prompt, and up-to-date context, by the way. So that one, all of this, like the context plus the original prompt. So there's the original prompt in here, and there's the context. All of these are going to be provided later on to the LLM. So saying, oh, this is actually the prompts. This is the new up-to-date context. Please use this context and your knowledge. And this will allow it to basically answer an up-to-date or simply give you an up-to-date response. So RAG is simply this middle component right over here. So to better understand how RAG works and how it's being implemented behind the scenes, I've got a simple Jupyter network in here that actually uses Python and uses a bunch of other technologies or tools to implement a very simplified RAG. And all of that is basically happening locally. So first, we're going to use LangChain, which is a very awesome framework that allows you to develop and create applications on top of LLMs. It just makes the whole process a lot simpler. It provides you with awesome ICE tools. And it's also available for both Python and JavaScript or Node.js. We're also going to be using Coordinate in here, which is a high-performance vector search database that actually implements the, vector similarity search technology, which of course we're going to be using for contextual extraction or for our RAG retrieval module. And last but not least, your LLM of choice, whether you can use ChatGPT from the API, or you want to use Llama 3 from like Ollama or LM Studio, or just deploying it locally, whatever LLM works perfectly. So here I've created this really awesome Jupyter notebook in here that basically installs all the stuff that we needed in here. So like LangChain, OpenAI, Playwright, there is Syntax Transformers, the different like Grok integration in here, LangChain Grok, LangChain OpenAI, and so much more. So first you need to make sure like you have Playwright installed in here by just running this one. You only need to run it once. Then I'm just like loading in here the .env in here, environment variables from the .env file in here, or from the actual environment variables. And here is actually where we load the data. So of course, you might actually be able to skip this step because you already have the data in a database, and you want to actually take that data and actually migrate it or move it, or what we say is embed it into that vector search database. We don't have the data or something, so we're going to go ahead and grab the data from the web. So for example, we've got this article in here about React 19, which is the latest React.js, which is like a UI framework on JavaScript, and it has been just released recently in here. And of course, most LLMs don't know or have any knowledge about this one, so that's why I'm using it for this particular demo and example. I'm simply just creating a function in here. I'm using the Chromium loader in here from Playwright to actually go ahead and load all the document data in here, just simple blog post, and just transferring it from HTML to text in here. And here we just go ahead and split it up, because you have to split it up into chunks of, like, I'm choosing 1,000 in here. I'm using like recursive character check splitter in here, but you can use different stuff in here depending on the scenario. But for us, it works really well like this way. Or you can actually go ahead and load the data from Paragon. So you can, if you just want to access like different news articles that are super real time and up to date, you can go in and use the Paragon sort of API in here that we offer. So you can just sign up on, goparagon.com/signup and get your API key to access it. And simple as that, you can go in and use the API. For example, in here, I'm searching about, the Paragon. I'm just searching about the React 19, which has a lot of articles about that one from Medium and different stuff. So I'm just searching about this one. It's going to actually return to me all the articles related to React 19 in here after doing the request. So after doing that, I just go ahead and transform the articles in here into an actual document, and I do the docs transform it in here as well to make them like a LangChain sort of compatible documents. And it just do all of that, do the splitting again, and it return the chunks document right over here. All right, so the next step in here is actually embedding the documents into the vector database or into our quadrant database. So whether you already have your database full of data and you want to take all of that data and actually embed it into the quadrant vector database, or in our case in here, because we already have the documents in memory, like, I've just got all the data in there, whether from the Paragon API or from somewhere else, you can just go ahead and take all of the documents and actually embed them into coordinates. For example, here I'm doing coordinates from documents, and of course I'm using the coordinates from LangChain in here. And LangChain, does provide like a plugin and an integration for using coordinates with an easy to use API. So as soon as I just import coordinates in here, I can use the from documents method, and I can just provide all the documents. For example, the documents I got from the web in here related to React 19. I can choose whatever model I want to use for embeddings. For example, I'm going to use this simple model from the Hugging Face embedding, which is the Sentence Transformers all MPNet based version 2. And here you want to actually select, like your instance of the coordinate database, because most of the time for production stuff, you want to run the database somewhere in your cloud setup, or you can use the coordinate clouds or whatever. But in our case here, for demo purposes, we want to just keep all the data in memory. That's pretty cool. And here we're just going to extract the retriever, and this retriever is actually the retriever from the rack components we were talking about before. That's going to be like the point where the prompt going to pass through this, going to grab some data from the context or the vector database, our quadrant database, and get back with the related context. All right, pretty cool. So next thing in here, just initializing the LLM model in here to work with LangChain, because we're using LangChain for basically just putting everything together in layers. So whether you want to use OLlama in here, if you have like a local model, which for example, Llama 3 8B, or if you're using Grok in here with Llama 3 as well, which I really recommend. They have really fast models in here. Or if you want to use OpenAI in here as well, it's all available. So choose whatever you want in here. For example, I'm just going to go with the Grok one because it's super, super fast. And here, actually the testing time. So first we want to test without RAG, like directly taking the prompt from the user right into the LLM in here, saying, oh, I want to ask, for example, this is basically just a simple setup in here, but the main query we're looking at is give me an example of using the new use action state hook for a login form. As curious in here, I'm using Grok as an LLM, so I can just go ahead and run this one. So the response in here, if we just go and look at the provided login components sort of example in here, so this is the hook we're looking for, and this is basically the newly released hook on the React 19. So the use action state in here, and it tries to use it like this, which is very wrong, and that's not what it is. So that's basically like a simple example of hallucination. It tries to come up with how the use action state works, even though it doesn't have any information about it. And it has, none of the information about this on its training data, so it knows literally nothing. So it tries to come up with things about this one to make it feel and look right, which is absolutely wrong. So that's a very, very brief example of like hallucinations, and it makes it look really right, even though it's not. Now, let's go ahead and see the example where we are actually using the RAG and using, the new information about the React 19 use action hook and everything. So right over here, we're just simply preparing a simple template. And this is actually what I was talking about before, where you provide the prompt or the original user's prompt alongside the actual context that you just retrieved from the vector database, which basically has all the recent up-to-date news or data about whatever the user is asking for. So simply we say, oh, instructor answer the question based on latest knowledge. We give it the context in here, and here we give it the original user question or prompt. And of course, we just go ahead and like put the LLM chain in here. I'm just using Grok Llama 3 in here. And for this one, I'm just going to, pass the context in here to the LLM chain in here. So the query is going to be basically the same thing, or the prompt is going to be basically the same thing. And now if we go ahead and run this one, it should be very quick, just provides the context. Now it tells you this example is action state from login form in React 19. So it knows exactly from where it gets that. It gets it from the right way, or it imports the hook from basically the right module, the React module, and it uses it the right way. So you use action state in here, there's submit action is pending. It basically just gives you a complete right solution right away. Even uses the form in here, uses form actions in here, the perfect solution, literally. So now because it has the context, it has the knowledge, it can answer that correctly. And that's basically what a RAG allows you to do. So to better see RAG in action, there's actually a really awesome example in here we can use. For example, there's this Champions League final match that is happening between Dortmund and Real Madrid, which is taking place in England and actually happening on June 1st. So this is basically the official website. It's basically just stating, oh, this is happening on the Wembley Stadium in London. There is, it's happening on Saturday, June 1st. There's a bunch of information here. And there's, even if you just scroll down, there's like predicted lineups or maybe potential lineups of both teams, and basically so many other information related to that news. And of course, because this is a very new thing, so LLMs like ChatGPT, Llama, or any other one won't have any up-to-date information. So a RAG can solve this issue. So for example, I already got the data from the previous article in here. I'm going to test this without a RAG, so directly asking the LLM in here. So for example, I'm just going to go ahead and run this one. And for the response in here, it simply says the date is going to be Saturday, May 28th, 2023, which is super outdated. That's happening in Turkey, Istanbul. No, that's pretty wrong. So this is like 1 year outdated already, which is very, very bad. And if I scroll down a little bit in here to use the RAG thing in here, I'm basically asking the same question, where to watch, match date, and possible lineups for Dortmund versus Real Madrid finale. So it's telling us in here the match date is Saturday, June 1st in here, and the possible lineups, it looks like for both teams is actually very correct. I'm looking to the website in here. Yes, it got the correct information. So again, RAG saved the day for us.